Good afternoon. I think you have watched the last video on the problem on Stokes theorem, and in this video we'll discuss about Coulomb's law of force and electric field intensity. So we'll move on to unit number 2, which is electrostatic fields. Okay. So before that, I would like to know what is electrostatics. So electrostatics is generally a branch of physics, and it deals with the study of electric charges at rest. Okay. So when electric charges are at rest, there will be so many phenomena occurring and different parameters associated with that. And in this unit we study about what is that phenomena and what are the parameters associated. And first of all, we will discuss about Coulomb's law. Okay. So electrostatics in general is study of electric charges at rest. So that is what electrostatics is all about. Okay, right. So there are so many applications of electrostatics in our day-to-day life, but we will discuss them at the end of this unit. Okay, right. And right. And before going into Coulomb's law, let us note a very important thing, which is what we call as point charge. So what is a point charge? So in most of the definitions we say that point charge and point charge. So a point charge is defined like this. So if a charge is occupying some volume in space, and if that volume is very small in comparison to the surrounding dimensions. Okay, so if a charge is occupying some volume, and if its dimensions or if its volume is very small compared to the surrounding dimensions, then we call that charge as point charge. Okay, now with these things in mind, so we'll move on to Coulomb's law. So Coulomb's law of force. So in what way Coulomb's law of force will help us? Okay, suppose if you are having 2 point charges or some charge distributions. So if you would like to know what is the amount of force of attraction or repulsion between these 2 charges, then Coulomb's law will help us find that. Okay, you might have studied Coulomb's law in your school also, but we will focus more on discussion through vectors. Okay, right. And before going into writing the actual expression for Coulomb's law of force between 2 charges, so let us write down the normal definition. Okay, so according to Coulomb's law, the electric force between 2 charges is directly proportional to the product of the 2 charges. So this is the first thing. And second point is indirectly proportional to the square of the distance between them. That is distance between the 2 charges. And third point is, and this electric force acts along the line joining the 2 charges. So this is what Coulomb's law says. So if you are having 2 charges, then if you would like to know the electric force between the 2 charges, so because when you are having 2 charges, each one of them may exert some force on the other. and depending upon the types of charges, and we already know that like charges will repel and different charges will attract. Okay, right? So as per Coulomb's law, so when you're having two charges, the electric force between those two charges is directly proportional to the product of the two charges, and indirectly proportional to the square of the distance between them, and the force acts along the line joining the two charges. Because when you say 2 point charges, they will be located at 2 points in space, so we can draw a distance vector between those 2 points, and the force acts along that line joining those two charges. Okay, so let us write down an expression for the force acting or force between the two charges. Okay, so for this, what we will do is we'll take charge Q1. This is say Q1, and Q1 is located at some point in space. So Q1 is a point charge which is located, that means it is having some position in space. And similarly, this is Q2, is also located at some point in space. So let us consider as this as origin. So when you draw a line from origin to a point, so this is a position vector. So let us indicate this position vector as R1 bar. Similarly, let us draw one more position vector to Q2 point, which is R2 bar. Now these are the two charges now, Q1 and Q2, located at 2 points, and R1 bar and R2 bar are the corresponding position vectors. Now let us draw a vector joining these 2 points. Now the first thing what we will do is, let us have an expression for force acting on Q2 due to Q1. That means the charge Q1 will exert some force on Q2. So I will draw a vector from this point directed to this point. So this is the direction. So now, as per our vector addition rule, addition of R1 bar and this vector, use this vector. So this vector which we drawn from 1 to 2, let us denote this as R1 2 bar, which is equal to R2 bar minus R1 bar. This is the distance vector. Okay, so now, so with this picture in mind, let us write down the force acting on Q2 due to Q1. So this is what we are going to write. So F12 bar, so the force acting on Q2 due to Q1, so that is what the suffix indicates. So F12 bar is equal to, as per the definition, F12 bar is equal to, so let us write not equal to, we'll move with proportionality constant. Okay, so the definition says the force acting between two charges is directly proportional to the product of two charges Q1 Q2 and inversely proportional to the square of the distance between them. So what is the distance vector R12 bar? And the distance will be the magnitude of R12 bar. So let us say the magnitude of R12 bar is equal to R12 in short. So as per the definition, the force acting between the two charges, or the force between the two charges, is indirectly proportional to the square of the distance between them. So R12 square, and it acts along the line joining the two charges. This is the line that is joining the two charges, and R12 bar is the corresponding distance vector. So we need only the direction. So what is the direction of r12 bar? It is the unit vector. So ar12 bar is the unit vector which gives the direction of this line r12 bar. So which is r12 bar divided by r12. So this unit vector acts along the direction from q1 to q2. So ar12 bar. So this is the statement what we got according to the definition. So in order to write equality symbol here, we have to keep some proportionality constant. Okay, so that proportionality constant is given by, so f12 bar is equal to k, which is the proportionality constant, q1 q2 r12 square ar12 bar. And this proportionality constant k in SI units is given by 1 by 4 pi epsilon. So as per the parameters involved here, because force will be in newtons and q1 q2 will be in coulombs, and r12, which is the distance, will be in meters. So the parameter k is having the units of meter per farad. So that is what the proportionality constant is having its units, or it is having its units as, I can simply write down as meter square, Newton meter square per Coulomb square. So this is the units of the proportionality constant k. And now what about this epsilon? So epsilon is called as dielectric constant or permittivity. So epsilon, which is called as dielectric constant or permittivity, so it does have units of Coulomb square per Newton meter square, or we can write down as farad per meter. So these are the units of this dielectricity constant or the proportionality constant. Okay, so after substituting the proportionality constant into the expression, okay, right, so if you see this, if you substitute the proportionality constant here, k is having units of Newton meter square per Coulomb square. So force is having units of Newton. Okay, so if I substitute k here, okay, so it is having Newton meter square per Coulomb square. So denominator I am having Coulomb square here, so let me substitute here. So Newton meter square per Coulomb square, which is for k, multiplied by q1 q2 will be having units of Coulomb square, and r12 square will be having units of meter square. So meter square cancels, Coulomb square cancels, and finally newtons. So the units of k is either Newton meter square per Coulomb square or meter per farad. Okay, right. So now let us substitute the proportionality constant here to write down the final expression of your force. Okay, so what we got finally is the force acting on 2 due to 1 is given by q1 q2 by 4 pi epsilon r12 square ar12 bar. So if this is the position of q1, if this is the position of q2, and if you draw a vector from q1 to q2, and this is r12 bar, then f12 bar acts along this direction. So that is the force acting on Q2 due to Q1. So is given by this expression. This can be further simplified. So which is equal to Q1 Q2 by 4 pi epsilon R12 square. So what is AR12? AR12 is R12 bar divided by R12. So which can be written as Q1 Q2, and R12 bar is R2 bar minus R1 bar, where R2 bar is the position vector of the point of where charge Q2 is located, where R1 bar is the position vector of the point where Q1 is located. So divided by 4 pi epsilon. Here I am having R12 square, here R12. Okay, or simply this will become R12 cube, or in other way. So what we can write is magnitude R2 bar minus R1 bar magnitude whole cube. So this is the final expression for your force acting on charge Q2 due to Q1. Okay, and units is newtons. This is F12 bar. Okay, so in a similar way I can write down the expression for F21 bar. Okay, right? So F21 bar means the force acting on charge Q1 due to Q2. So for that, the only change what we need to do is, so again let us, this is Q1 at some point and Q2 at some point. Now we would like to find the force acting on Q1 due to Q2. So then what we will do? So we will draw a vector from the point where Q2 is existing to the point where Q1 is existing. So this is the vector now. So this vector is now R21 bar, and this is F21 bar, and it is in this direction. Okay, now if you see the only difference, earlier R12 bar is in this direction, now R21 bar is in exactly opposite direction. Okay, so from this, if you want to write down, so I can write down this. So Q1 Q2. Now what is R21? So R21 bar will be, so let us draw the position vectors also. So this is origin, so now this is origin to Q1 line, and this is origin to Q2. This is R1 bar, this is R2 bar. Now from this, again using vector addition rule, R21 bar will be equal to R1 bar minus R2 bar. Okay, right? So with this information, what we can write down is the force acting on charge Q1 due to Q2 is given by R1 bar minus R2 bar divided by 4 pi epsilon magnitude R1 bar minus R2 bar whole cube. So this is what we get when we write down the force acting on Q1 due to Q2. And as if you can see clearly, this is magnitude cube, this is also magnitude cube. So when you are having two vectors which are having the same distance, so this parameter is same and this parameter is also same. Okay, now if you look at these two parameters, F12 bar and F21 bar, the only difference is in the numerator, which is here we have written R2 bar minus R1 bar, and here we have written R1 bar minus R2 bar. So the only difference between F1 bar and F2 bar is the change of direction. That means F12 bar is in a direction exactly opposite to the direction of F21 bar. So with this we can write down as F12 bar is equal to minus F21 bar. So this is what we can write. Okay, right? So this is about your Coulomb's law. Okay, so given 2 point charges Q1 and Q2 located at two different points, and according to Coulomb's law, we can write down this expression. Okay, right? So F12 bar is equal to Q1 Q2 R2 bar minus R1 bar by 4 pi epsilon, magnitude R2 bar minus R1 bar whole cube, newtons. Similarly, F21 bar is equal to Q1 Q2, this time R1 bar minus R2 bar divided by 4 pi epsilon, magnitude R1 bar minus R2 bar whole cube. So this is the Coulomb's law. And earlier we discussed about the dielectric constant epsilon. So epsilon is dielectric constant or permittivity. Okay, so epsilon has units of as discussed earlier, so Coulomb square by Newton meter square or Farad per meter. Okay, so this epsilon depends on the material we choose, different dielectric materials, and most of the time we do use the material as free space. So for free space, so we denote epsilon as epsilon naught, which is 8.854 into 10 power minus 12 farad per meter. So this is the value we need to remember. Of course, you will get this value in your calculator also, but this is the dielectric constant of free space. Or while doing problems, most of the time we need to substitute 1 by 4 pi epsilon naught. So this parameter is approximately equal to 9 into 10 power 9 meters per farad. Okay, right? So in problems while doing to find out the force, so if you are ever substituting 1 by 4 pi epsilon naught, then you directly substitute this value, 9 into 10 power 9 meters per farad. Okay, right? So let us summarize the expressions for your Coulomb's law. So if Q1 and Q2 are two charges separated by some distance, if this is R12 bar, then the force F12 bar acts along this direction, and F12 bar is given by, so Q1 Q2 into R2 bar minus R1 bar divided by 4 pi epsilon R2 bar minus R1 bar magnitude whole cube, newtons. Similarly, F21 bar is exactly minus of F12 bar. So this is for 2 point charges. Okay, right? So now what if we are having multiple point charges? Okay, so what if you are having more number of charges, right? So let us see that case. So number of charges. So let us say you are having a point charge Q somewhere here. So at this point you are having some charge Q. So let us say this is origin, and let us say we are having some n number of charges somewhere here, somewhere here, and somewhere here, dot dot. Okay, so let us say this charge is Q1, this charge is Q2, this charge is Q some n. There are n number of charges. So I would like to find what is the force exerted on this charge q located at this point. Okay, so for that, let us first draw the unit vectors. So not the vectors, the position vectors. So let us say this vector as r bar. The position vector drawn from origin to the point where q is located. So because we would like to find the force acting on the charge q due to n number of charges. Okay, and similarly, now this is the position vector of q1, which is r1 bar, and similarly this is the position vector of q2, which is r2 bar. In a similar way, we can draw the position vector for qn also, which is rn bar. Okay, right? So we have taken a charge q which is located at some point with position vector r bar, and we have taken n number of charges, so q1, q2 and so on qn, and r1 bar is the position vector of q1 and r2 bar is the position vector of q2 and so on, rn bar is the position vector of qn. So if you would like to find out the amount of force acting on charge q due to this n number of point charges, then we have to apply Coulomb's law by considering superposition. Okay, right? So according to superposition, when I want to find out the force acting on q due to all the charges, so I will first consider only q1. So first considering q1, and then I will find the force acting on q due to q1 alone, and in that case I will assume that q1, q2 and so on qn are not present. Okay, so first find out what is the force acting on q due to q1 alone, and then assume that only q2 is present. Then find the force acting on q due to q2 alone, and so on. Find the force acting on q due to q1 alone. Add all these components to find the force acting on q due to all these n number of charges by applying superposition principle. Okay, now let us draw the distance vector from the point where q1 is located to the point where q is located. So this is the distance vector from the point where q1 is located to the point where q is located. So let us call this, now as per this figure, if you see these two, okay, so this vector is given by r bar minus r1 bar. Okay, right? So now we will find the force acting on q due to q1 alone. So the first component, so we'll write down as F due to 1 on charge q. So the force acting on the charge q due to q1, so that is what I am going to find. So as per our definition, it is q into q1 divided by 4 pi epsilon, and what is the distance vector? R bar minus r1 bar. Okay, right? So r bar minus r1 bar. So r bar minus r1 bar divided by magnitude of r bar minus r1 bar whole cube. So this is the force acting on the charge q due to q1 alone. Similarly, I can draw a the distance vector from the point where q2 is located to the point where q is located. So if I draw a vector like this, now, so if you look at this, this distance vector is r bar minus r2 bar. So this distance vector is r bar minus r2 bar. So now I will consider only q2 alone. So considering q2 alone, I will write down F2q bar, that is the force acting on the charge q due to q2. So which is given by q2 by 4 pi epsilon, and what is the distance vector this time? R bar minus R2 bar. So R bar minus R2 bar divided by magnitude R bar minus R2 bar whole cube. So this is the force acting on Q due to Q2 alone. Okay. Now similarly and so on, I can write down the force acting on Q due to Qn alone. Okay, right? So force acting on Q due to Qn. Okay, right? So this is given by Qn divided by 4 pi epsilon, and now this time the distance vector will be r bar minus Rn bar divided by magnitude r bar minus Rn bar whole cube. So now, so this first parameter is the force acting on the charge Q due to Q1 alone. Similarly, this parameter is the force acting on Q due to Q2 alone, and this is the force acting on Q due to Qn alone. So now applying superposition principle, so I will find out the final expression for the force acting on the Q due to all these n number of point charges. So I will sum all these things. Okay, so let us write down, that is as q1 4 pi epsilon, this is r bar minus r1 bar divided by r bar minus r1 bar, sorry, magnitude whole cube, plus q2 r bar minus r2 bar divided by 4 pi epsilon magnitude r bar minus r2 bar magnitude close cube, plus and so on, plus qn r bar minus Rn bar divided by 4 pi epsilon magnitude r bar minus Rn bar whole cube. So this is what the final expression is. Okay, so we can put this final expression as a summation. As you can see, in all these terms one thing is common, q by 4 pi epsilon, this is common, and the index is varying from 1, 2 and up to capital N, because we considered n number of point charges. Okay, so if I want to write down the final expression, the force acting on Q due to n number of charges is given by F bar is equal to Q by 4 pi epsilon. So this is the common thing in all these expressions, and I will write down the summation I is equal to 1 to capital N, because I have considered n number of point charges. So F bar equal to Q by 4 pi epsilon sigma I equal to 1 to N. So Q I in brackets R bar minus R I bar bracket close divided by magnitude R bar minus R I bar whole cube. So this is the expression for the force acting on the charge Q due to n number of charges, that is Q1, Q2 and so on, Qn. Okay, right. So this is all about your Coulomb's law of force, and how Coulomb's law of force helps us to find out either the force of, what is the amount of force of attraction, or what is the amount of force of repulsion between the two charges given, and in which direction the force acts. Okay, right. And as said, most of the time we do consider point charges. Okay, and you need to remember the expression, I mean the value of dielectric constant epsilon, and it differs from material to material. Of course, while doing problems, the value of dielectric constant will be given, but for free space it is 8.854 into 10 power minus 12 farad per meter. Okay, right. And this completes our discussion about Coulomb's law. Okay, so to finally restate the Coulomb's law, so Coulomb's law of electric force between two charges is directly proportional to the product of the two charges and indirectly proportional to the square of the distance between them, and it acts along the line joining the two charges. Okay, right. So with these definitions and with these expressions, in the next lecture we will discuss about electric field intensity. So Coulomb's law tells us how much amount of force a charge experiences by another charge in the vicinity. If you would like to find out what is the electric force per unit charge, then that is called as electric field intensity. Okay, so we'll discuss more about electric field intensity in the next class. Thank you.